Hello everyone, welcome to yet another video of measurement and instrumentation. So in this video series we are discussing about the LEDs and its types. So last class we have discussed in last video we have discussed about the OLEDs. So in today's video we will see about QLEDs. So these QLED are quantum dot LEDs. So it is a nanocrystal made of semiconductor materials that are small enough to exhibit quantum mechanical properties. Researchers have studied applications for quantum dots in transistors, solar cells, LEDs and diode lasers. So in QLEDs we have let me make the screen visible to you, more visible to you. So in QLEDs we have 4 layers. One is the exciton, which is the electron hole pair, and then we have band gap, and then we have 0 point vibrational energy of the excited electron, and finally we have 0 point vibrational energy of the hole. So now we will see what is quantum dot technology. First, let's see what are quantum dots. Quantum dots are semiconductor nanocrystals that are able to absorb higher energy lights and convert it to lower energy light. The wavelength or the wavelength of the light or the color of the light that the quantum dot emit varies depending on their size. For example, the smallest dots with a diameter of just 2 nanometer emits blue color. The largest particles with a diameter of 6 nanometer emits red light. So based on the diameter of the light, the color varies. The quantum dots emit lights that are extremely pure and highly saturated. This is because they produce high spectral wave peaks than conventional materials, which results in a wide range of colors, especially red and greens, that are clearer and more accurate and truer to life. Quantum dots are also highly efficient at converting lights, so using the same amount of electrical power, they are able to generate high brighter colors than other materials. So these are the colors that are produced based on the size. So if the size is so small, the size of the quantum dot is small, it is blue color. If it is of medium size, we can get green color, and if it is extremely high, then we can achieve red color, and the wavelength corresponding to it are also being displayed in this graph. So that is why we have the conventional monitors with red, blue and green colors, and the combinations produces a mild blue, yellow and purple colors. So this is Samsung conventional colors, and this is Samsung quantum dot. You can see the peak wave and also its clarity. Now we will see how quantum dot is applied to monitor. So in the conventional monitor, we have a blue LED backlight and an yellow crossbar, and then we have this monitor screen. But in Samsung QLEDs, we have blue LED blacklight, and then in the yellow crossbar, we have, instead of yellow crossbar, we have quantum dot films, so which are able to give more vivid colors. You can see the comparison between the two monitors, wherein which the conventional monitors are colorful, but since the pixel quality is very high in QLEDs, It provides more clearer, crystal clear images in QLED monitors. For games also, so these QLEDs are not just used in for the purpose of projecting, taking movies, taking in sports also. So these quantum dots provide a good quality images compared to the conventional Samsung monitors. So this is how a QLED TVs work. You have a light source, then you have a color filter, and then you have a display. Applications. So quantum dot technology is one of the most promising candidate for use in solid state quantum computation. With several entangled quantum dots or qubits plus a way of performing operations, quantum calculations on the computers that would perform them might be possible. So these are the places where in which quantum dots are being used. In vitro imagings, quantum dots are widely used in vitro imagings for fixed cells and tissues, intracellular organelles and molecules, and membrane surface. And it also been used in vivo targeting of cells, tissues, organs, and tumors in animals, and for diagnosis, therapy, and drug testings. It also been used in bioanalytical assays such as fluorescent activated cells, sortings, analysis, and microarrays. It in near future it is find a recent good amount of application in biosensors, drug delivery, and disease treatments. It is also been used in photovoltaic devices wherein which you may be able to increase the efficiency and reduce the cost of today's typical silicon photovoltaic cells. Also, quantum dots photovoltaic would theoretically be cheaper to manufacture as they can be made using simple chemical reactions. This is how this implementation of quantum dots is. First, we need to have a design and fabrication process and characterization, and then the computing segment. So, on a nutshell, quantum dots is a nanocrystal made of semiconductor materials that are small enough to exhibit quantum mechanical properties. There are several ways to confine excitons in semiconductors, resulting in different methods to produce quantum dots. Also, the research effort around the world is being applied to expanding accuracy and capabilities of these nanoparticles for its usage in the industry of hardware components and electronics, as it is one of the most promising candidates for use in solid state quantum computations. So the future works includes focusing on applications of quantum dots in hardware structure of microcomputers, integrated circuits, silicon chips, and methods that preserves the unit necessary to power lightning fast viable computers known that uses hole spin rather than electron spin, that keeps the quantum bits in same physical state up to 10 times longer than before. So these are the concepts regarding the quantum dot LEDs or the QLEDs. Hope this video is useful to you. With this, we come to the end of this video. We'll meet you again at another interesting topic. Thank you. Happy learning.